Now, based on the same logic, let's see the problem on the board to find out the points which are intersecting a given line segment. Their coordinates we have to calculate. So if AB are the 2 points, find the coordinates of the points which divide this line AB into 5 congruent parts. So again, let's pen down the problem diagrammatically. This is your segment AB, right? It is dividing into 5 congruent parts. So let's check out 1, 2, 3, 4 and 5. The ratio is 1 is to 1 is to 5 congruent parts. That's my equal ratio, right? So let's assume the given points intersecting line AB are P, Q, R and S. The coordinates of point A are given as 20, 10. Definitely, we always assume them as x1, y1. Point B, the extreme right point, the coordinates are 0, 20. So definitely, we assign the value for the values as x2, y2. Now, we have to entirely find out the values of coordinates of P, Q, R and S. To begin with, can we first use a midpoint formula where it is dividing m is to n into equal ratios? No, because you have got 5 congruent parts. So definitely first we have to go in with section formula. But in that also, think logically, children. Check over here. If I find point P first by using section formula, then once I know the coordinates of P and B, I can see that R becomes the midpoint. 2 is to 2 ratio. So I can use the midpoint formula to find out R. Once I know R, I will find out point Q because it is 1 is to 1 ratio, again by midpoint formula. I can find out S by using RB segment because again the ratio is 1 is to 1. That means in this problem, to move on to find out the entire coordinates of these points, I will have to use section formula only once to either calculate point P or you can calculate point S. If you want to calculate point S, your m is to n ratio will change. It will be 4 is to 1. If you want to calculate point P, your ratio will be 1, that is AP, is to PB, that is 1 is to 4. But later on, to calculate the remaining points, their coordinates, I will only use the midpoint formula, which saves my time. So, to calculate point P, to calculate coordinates of point P, we will use section formula. To use section formula, the value of coordinates of point P will be assumed as xy. So to calculate x by using section formula, the formula is nx2 plus nx1 upon m plus n. Now what is m and what is n? We are going to use segment AP is to segment PB to calculate m is to n. So m over here will be 1 to calculate point P and entire QB will be 4. That is the value of n. So m is to n will be 1 is to 4. That is m is to n will be equal to 1 is to 4. That is AP is to PB. To be more precise way. So let's calculate. X will be equal to m, that is 1, mx2, 0 plus n, that is 4 into x1, that is 20. upon m plus n, 1 plus 4. So x is equal to 1 into 0 gives you 0 plus 4 to 420s are 80 upon 5. To move on with our calculations, 0 has no value, it can be discarded. So 80 upon 5. Let's reduce. 5 ones are 5, 5 ones are 5, carry 3, 5 6 are 30. So x is equal to 16. So we got the value of x, that is 16. Now let's calculate the value of y by using again the section formula. So here y is equal to my2 plus my1 upon m plus n. Thus y is equal to m is 1 into y2 20 plus n is 4. y1 can be substituted as 10 upon m plus n, 1 plus 4. To move on correctly with our calculations, y will be equal to 20 ones are 20 plus 10 fours are 40 upon 5. So y is equal to 60 upon 5. 5 ones are 5 ones are 5 twos are 10. So y is equal to 12. So let me plot over there the value of y. Y is equal to 12. To calculate the value of point R, if we go to C, we have calculated the coordinates of point P. To calculate R, I can definitely use the midpoint formula by considering only the segment PB. So, to calculate point R, let's consider segment PB. Why, children, we consider PB? Because R becomes the midpoint. 2 is to 2 ratio. That means m is to n is equal. So we can use directly the midpoint formula. So in order to calculate point R, let's consider point segment PB. Thus, by using the midpoint formula, let's see, the coordinates of point P become x1, y1, point B become x2, y2, and the coordinates of point R will become x, y. So let's calculate x. We get the ratio equal. So x will be equal to x1 plus x2 upon 2. So x is equal to 16 plus 0 upon 2. So x is equal to 16 plus 0 is 16 upon 2. Let's reduce. 2 ones are 2 eights are. Therefore, x is equal to 8. To calculate the y coordinate of the same point, the formula used will be y1 plus y2 upon 2. So y will be equal to 12 plus 20 upon 2. So y will be equal to 32 upon 2. Let's reduce. 2 ones are 2, 2 16s are 32. So y is equal to 16. So thus we got the value of point R by using a simpler formula, that is midpoint formula. Now we have to calculate the coordinates of point Q and S. To calculate Q first, if we want, definitely we can reduce the segment and use only PR as the segment and use the midpoint formula, because m is to n again has the same value, 1 is to 1. So to calculate point Q now, let's consider which segment? PR. And thus by using the midpoint formula, let's calculate. So children, it goes very easy. First you only use section formula and then midpoint formulas. But let's change our assigned values of coordinates. P remains x1, y1, but R can be assigned the value as x2, y2, and for point Q, that is the unknown, will be x1 for us to calculate. So again using the midpoint formula, x is equal to x1 plus x2 upon 2, that is x is equal to 16 plus x2 now, that is 8 upon 2, 14 upon 2, so x is equal to 2 ones are 2 sevens are, x is equal to 7. Please check, children. 16 plus 8 will give us 24. 2 ones are 2 12s are. So x is equal to 12. Once again I repeat, x1 plus x2, 16 plus 8. Substitute upon 2. Don't forget the denominator. So 16 plus 8 gives us 24. 24 upon 2. Let's reduce. 2 ones are 2 ones are 2 2s are 4. So x is equal to 12. Let's pen down the answer. Now y is equal to, again by using the midpoint formula, y1 plus y2 upon 2. So y will be equal to, let's check what is y1, 12. What is y2? 16. 12 plus 16 upon 2. So y is equal to 28. 12 plus 16 is 28 upon 2. Can be reduced? Definitely. So y is equal to 14. Let's pen down the answer. Y is equal to 14. So we are entirely getting the values of all the points, which is dividing segment AB into 5 congruent parts. Now to move on with, to calculate the value of point S. Let's change our reference segment, line segment, from PR to RB. So over here, to calculate the value of point S, let's consider which line segment? Segment RB. So our reference changes, children. Over here, if you are going to consider RB, for point R, let's assign the value x1, y1. For point B, it will be x2, y2, and point S. Let's assume the coordinates are xy. Again, to calculate point S, let's consider the segment RB. Why? So that we can use the midpoint formula. So to calculate x, it will be x1 plus x2 upon 2. Let's substitute carefully. xy, 8 plus x2, 0 upon 2. So x is equal to 8 upon 2. 2 1 2 4. So x is equal to 4. Now, to calculate y. Y is equal to y1 plus y2 upon 2. Thus y will be equal to y1, that is 16 plus 20 upon 2. That gives us in the numerator 36 upon 2. Let's reduce 2 ones are to 18. So y is equal to 18. So the value of y, by using again this midpoint formula, is x is 4, y is 18. So what did we see, children? First, by using the section formula, we calculated the value of P. Then we calculated the coordinates of point R by using the midpoint formula. Then Q again by using the midpoint formula. Same with in the case of point S. So by using only two formulas, we were able to calculate the coordinates of the points, which is dividing segment AB into 5 congruent parts. That is point P with coordinates 16, 12, Q with coordinates 12 and 14, R with coordinates 8 and 16, and the last one, point S, with coordinates 4 and 18. So children, thus the coordinates of the points dividing segment AB into 5 congruent, this word is very important, congruent parts are P 16, 12, Q 12, 14, R with the value 6, 8 and 16 as the xn coordinate, y coordinate, and point S with coordinates 4 and 18. So this is the way we found out the value of the unknowns.